So, okay, we are back again. This here I have your what you call reduce this thing from 200% to 100%. First I have to explain regarding this diagram, because then understanding will be clear, right. Hope everything will be readable to you. If I enlarge it, then it is just crossing that your what you call this monitor, this screen, right. So, first that problem, after that I will tell you fault and other thing, right. So, first is the problem. So, here it is actually 3 generators, generator 1, generator 2 and generator 3, 3 generators are there, right. And your that this is bus 1, this is the voltage behind your transient reactance, this way it has been marked x d 1 dash, this is bus 2, it is x d dash x d 2 dash, right. And this is your bus 3, it is x d 3 dash is given, right. And this is bus 4, bus 5 and bus 6, bus 7, bus 8. This is a big example, but it will not be asked in the exam or assignment to compute so many things. Many data will be provided to you such that you can compute easily, right. I mean such that you can do it in the classroom exercise, but this example is taken such that it will your clear it will clear your concept or doubt, right. And this is one. So, all these things, then this is voltage, your this voltage is your E 1 angle delta 1, magnitude I have made, the E 2 angle delta 2 and this is E 3 angle delta 3, right. This bus is a slack bus, right. This bus is a slack bus, voltage is 1.04 angle 0. Now, this bus 5 is a PV bus, right. This bus is a PV bus, voltage magnitude is specified, right. And this bus 6 also is a PV bus, voltage magnitude is specified. Later I might have mentioned everything, right. And second thing is bus 7, the load is given in per unit, bus 7 load, this is S 7, 2.8653 plus J 1.2244. This load is given P and Q. Similarly, at bus 8 load is given 1.4 plus J 0.4, this load is given, right. And here Pg2 is 0.661, right, per unit, and here also Pg3 1.60, right. So, these are the data given and some and other data are mentioned now, right. Just hold on. So, this is the problem, just hold on, let me enlarge it now, right. So, this is the diagram I showed you, right. Now, now for the transmission line in the system, all the shunt elements are capacitors with an admittance of Y c is equal to J 0.1 per unit, right. So, all the shunt elements for transmission line it is J 0.1 per unit is given, while all the series elements are inductors with an impedance of Z L is equal to J 0.1 per unit, right. This data given. The desired voltages, generation levels and the load levels are indicated in the figure. Fault I will tell you later, right. So, that figure, this figure small your what you call I told everything, right. So, now this data are given, x d 1 dash is given J 0.08 per unit, everything is per unit, x d dash x d 2 dash J 0.18 and x d 3 dash J 0.12, right. H 1 that is inertia constant for machine 1 10 second, H 2 3.01 second and H 3 6.45 second. The power flow solution also is given, right. So, for the assignment or exam purpose we will provide the power flow solution such that otherwise we will not ask you to solve this, you need computer, right. So, power flow solution V 4 is given 1.040 angle 0 degree, I told you it is a slack bus. V 5 is 1.02 angle minus 3.55 degree, this is the load flow solution. V 6 is 1.05 angle minus 2.9 degree, V 7 is 0.9911 angle minus 7.48 degree and V 8 is equal to 1.0135 angle minus 7.05 degree. These are the load flow solution. Along with this, Pg 1 is 1.991 per unit, Qg 1 is 0.8134 per unit, everything is in per unit. Pg2 0.6661 per unit, Qg2 0.2049 per unit, Pg3 is equal to 1.60 per unit and Qg3 1.051 per unit. All these things are given, right. Knowing the voltages at the load buses and the complex power demand, the admittances corresponding the loads are given by, I mean when you come to this diagram, that this for the transient stability analysis, these loads are given, we have to convert this load in terms of your what you call that admittance, right, and this will be considered as a shunt element. So, in this case generally we know that PL minus JQL, we have discussed all these things before, but I am just telling in general PL minus JQL is equal to V conjugate I, right, this is the thing. Now, that means PL minus JQL, right, divided by, I mean if you divide both sides by V, that means is equal to V conjugate I by V, I am overwriting on it, right. That means my I by V, this is my admittance, right, is equal to PL minus JQL divided by this V conjugate into V, bring this one to this side, this V conjugate and bring to this side. So, V into V conjugate, it will be basically V square, the magnitude, right, voltage square magnitude. So, that means this my Y, this I by V actually Y, that is if it is for a load, then YL, it will be IL is equal to PL by V square, YL is equal to then minus J QL upon V square. So, this way we have to transform this load into admittance, right, load admittance. So, that is why we have converted this your Y, that bus 7 we will make, because we have to convert it to your what you call the admittances. So, we instead of Y 7 we are writing Y 7 PL 7 upon V 7 square, because it is bus voltage at V by your bus 7, right, and minus JQL 7 upon V 7 square, just I told you how to make it, right. So, PL and PL QL and V 7 magnitude all are known, right, and after the load flow studies everything is known. So, if you compute this, right, then Y 77 will become that your 2.8653 and V 7 is 0.9911 square 11, so its square minus J 1.2244 upon 0.9911 square. So, this is actually coming your 2.917 minus J 1.2465 per unit, right. Similarly, you calculate Y 88, right. So, similarly for Y 88 you will calculate, that is your whatever load is there at that bus PL 8 upon V 8 square minus J QL 8 upon V 8 square, right. So, if you compute you will get 1.363 minus J 0.38 your 94 per unit, right. I have not written everywhere per unit, but it is understandable. Now, using equation 9, right, using equation 9, that internal generator voltage can be calculated as, right. So, that means your E1, E2 and E3 we have to compute. So, equation 9 it is already derived, equation 9 everything is derived, the derivation is given. So, for generator 2, that is your for generator 2, that is your P2 plus JQ2 is equal to, this is my P2 and this is my Q2, right, 0.6661 plus J 0.204, it is only after everything after load flow studies, right, and V5 is given 1.02 angle minus 3.55 degree, right, this is given. So, this is V5 and this is my your delta 5, XD2 dash XD2 dash also given J 0.18. So, go back to equation 9, you go back to equation 9, right. So, we can write magnitude of E2 angle delta 2 dash from equation 9, right, is equal to V5, that means this voltage magnitude V5 plus, right, that Q2 into XD2 dash. So, this is Q2, this is my Q2 into XD2 dash. So, this is my XD2 dash divided by your what you call that V5, that is 1.02, right. plus j, go to equation 9, it is P2 0.6661 into xd2 dash divided by V2, that will give you your magnitudinal angle of the your internal your generator voltage, terminal voltage, right. So, if you do so, you will get E2 angle delta 2 dash is 1.0627 angle 6.3507 degree. Therefore, what will be delta 2 0? It will be 6.3507 minus 3.55, because your this voltage, this angle voltage V 5, it is minus 3.55 degree, right. Therefore, this one delta to 0 will be 6.3507, that means this degree, this one minus that 3.55, it will be 2.8006 degree, that is my delta to 0, right. Similarly, you please calculate your E3 angle, your E1 and your E3, right. Similarly, we have computed that E1 angle delta 10 will be 1.1132 angle 7.9399 degree, and E3 angle delta 30 will be 1.1844 angle 5.9813 degree. Note that this is delta 2 dash, right, this is delta 2 dash, right. So, basically delta 2 0 is equal to delta 2 dash minus your delta 5, that is your bus voltage angle delta 5. So, that means here it is 2.8006 degree, that means my magnitude of E2 angle delta 2 0 is equal to your 1.0627, then this voltage 1.0627 and angle 2.8006 degree, right. So, that is why for 1 and 3 we are, instead of writing delta 1 dash delta 2 dash, right, we are writing E1 angle delta 10, E3 angle. If you please compute these two, to save the time, direct answer is given, right. Next is your Y bus pre-fault. Y bus pre-fault is 8 into 8 matrix, and Y bus faulted actually it is 7 into 7 matrix, right, that we will see later. And Y bus fault again will be 8 into 8 matrix, because one row and column will be eliminated. So, it will be your 7 into 7, right. So, and when you reduce it, that it is, there are 3 machines, So, pre-fault matrix will be 3 into 3 matrix, Y bus faulted also will be 3 into 3 matrix, and Y bus reduced, that post fault also will be 3 into 3 matrix, right, because 3 machines are there. For that example, Y bus pre-fault is 8 into 8 matrix, right. Whatever data were given, all these things were computed. I am writing capital Y11 is, you will give, I suggest these are all the non-zero element, other elements are 0, right, only non-zero elements I am writing. So, Y11 is minus J12.5, Y14 you will get J12.5. Similarly, Y22 you will get minus J5.556, and Y25 you will get J5.556. Similarly, Y33 you will get minus J8.333, and Y36 you will get J8.333. Just you can compute yourself, but for exam purpose or these parameters will be provided, right, otherwise because otherwise it is a time consuming process. Y41 will be J12.5, and Y44 you will get minus J32.48. Only I will request, when you will compute it, please see that all calculations are correct or not, right. If you find any computation error, you just put that question in the forum, right, I rectify that. Y45 will be J10, and Y47 will be also J10, right. So, and Y52 will be J5.556, Y54 will be J10, Y55 will be minus J35.526, Y57 you will get J10, and Y58 also J10. Now, Y63 you will get your J8.333, Y66 minus J28, Y67 J10, Y68 actually you will get J10. So, next Y74 you will get J10, Y75 you will get J10, y76 j10, and y77 you will get 2.917 minus j331.217, because here that your at bus 7 that load admittance is there, that we have the real and imaginary both parts are there. For the load admittance, that will be considered as a shunt admittance, and that is why it is a complex, it is a what you call is a real and imaginary part, both are there, right, in y77. Similarly for y8, that y85 j10, y86 j10, and y88 you will get 1.363 minus j20.369, because at bus 8 also you will find the load is there, right, and y bus faulted matrix, right. So non-zero element. So in this case it will be a 7 into 7 matrix. So non-zero element will be all y11 will be minus j12.5, y14 will be j12.5, and y22 will be minus j5.556, right, and y25 is j5.556. Now y33 will be minus j8.333, and y36 is j8.333, and y41 is j12.5, 44 will be minus j32.48, and y45 we will get j10. So y52 is equal to j5.556, y54 you will get j10, y55 you will get minus j35.526, and y58 you will get j10. Similarly y63 you will get j8.333, y66 you will get minus j28.313, and y68 you will get j10, right, and y75 you will get j10, y76 you will get j10, y77 you will get 1.363 minus j20.369. Actually that fault has occurred at bus 7, a 3 phase fault has occurred at bus 7. So from this y matrix, when you write that this is your full matrix, this matrix that is your 8 into 8 matrix, and this fault has occurred, a 3 phase fault has occurred at bus 7, right. So what we will do, that from this 8 into 8 matrix, that 7th row and 7th column, right, 7th column you completely eliminate, right, 7th row and 7th column you eliminate. So faulted matrix will be 7 into 7, right. So fault has occurred at bus 7, a 3 phase fault has occurred at bus 7. So this will be your what you call that your 7 into 7 matrix for bus faulted bus, right. It is bus fault has occurred at bus 7, and for your post fault case, the non-zero element, then again you will go back to 8 into 8, but in that case that your fault has your what you call that line was removed, right. So in that case, if you your just hold on, just let me go back to that diagram again, right, that just hold on, let me go back to that diagram again. Just hold on. Here, right. So when this fault has occurred actually at this thing but 3 phase fault at bus 7, such a voltage at bus 7 will be 0. So that line was completely your what you call that your that 7th row and 7th column was eliminated, right. So that's why matrix will become 7 into 7, but 3 lines are there. So just hold on, right. So this is your post fault matrix. If you come to that, so it will be 7 4, your 7 4, 7 5 and 7 7 are there, right, and here it is 8 5, 8 6 and 8 8 is there. If you go back 7 4, 7 5, right, and 7 7, so let me go back to that diagram 7 4 and 7 5, right. Let me go back to that diagram. So because it is just we are putting it away, right, just hold on. So this your 7 4, 7 5 is there, and I think line 7 and 6, where after the fault was cleared, that line 7 6 is out, right, line 7 and 6 is out. So if 7 and 6 is out, so 7 4 7 5 is there, so 7 6 y 7 6 will not be there. So that's why when fault is cleared, line 7 6 was out, right. So in this case, your for your post fault case, if you look into that, y 7475 77 is there, y 76 is not there, but when your pre-fault case, if you look into that, just hold on, 76 was there. So, when fault was cleared, that line 7 to 6 was removed, right, it is open. So, that is why your faulted matrix 7475 and 77 is there, and y 85 86 88 is there, right. So, this is your what you call that your post fault matrix. Now, if you just go for matrix reduction, that reduce y bus matrix, it will be coming like this. It is given that your because it's a 8 into 8 matrix or 7 into 7 matrix. So, inverse and other thing is impossible in the classroom, you need help of computer, but final if you do so, this data will be provided for your easy calculation. So, when you reduce to pre-fault one, that y 11 is this much is given, y 22 is given, y 33 is given, and it is a symmetric matrix. So, y 12 will be y 21 is this much, y 13 is equal to y 31 will be this much, and y 23 is equal to y 32 will be this much, right. And y bus faulted. So, 3 into 3 matrix, the reduced or reduced one, it will be 7 into 7 matrix after the reduced, right. 3 into 3, y 11 is given this much, y 22 is given this much, and y 33 is given this much, right. And y 12 is equal to y 21 is this much, y 13 is equal to y 31 is this much, and y 23 is equal to y 32, 23 is equal to 32 is equal to this much, right. And this is your during fault, right. So, this is 3 into 3 matrix, the matrix reduction, and then y bus post fault 3 into 3 matrix again. So, all y 11, y 22, y 33 are given, all off diagonal elements are also given, it is symmetric matrix, right. So, it is y 12 is equal to y 21, y 13 is equal to y 31, and y 23 is equal to y 32, right, these are given. So, this is actually power transfer is not shown here, just reduce matrix and how things are, that in the problem actually here that fault has occurred at bus 7, and after when fault was cleared, line 7 6 was removed, right. And you have to consider that represent that loads in terms of admittance, and you have to incorporate that thing in that y matrix, right. And this is another example, just hold on, I will reduce this thing little bit, right. So, this is another example we have taken. So, in this case that your before going to that fault and other thing, first we have to see that there are basically three generators, but this is E1 generator 1, this is generator 2, and this is your another one, that is infinite bus, right, that infinite generator we have made it like this, and this voltage, this is a slack bus 1 angle 0. So, in this case we are taking U1 is equal to V1 is equal to 1 angle 0, right. Now, the loads are given, and this is actually in this case this one and this one not considered as a bus number. I think it is not required, because this previous example there was no transformers, but here that transient reactances are there x d 1 dash and here also x d 2 dash, these two are there, but here we have your what you call put one transformer, and transformer reactances will be there, right. That means, whatever transformer reactance will be there, with that you have to add these two reactances and then you find out the admittances. So, that will be your y 22. So, you need not consider this one again and this one as another bus. So, things will be your what you call, it will be your no need, right, no need. So, that is one thing, but previous example there was no transformer, right. Now, another thing is that this bus your load flow result everything is given, and here at bus 4 that load is given, we have to convert this load in terms of your admittance same as before. Bus 5 also this load is given, we have to convert it in terms of admittance, right. And other things are that all the load flow solutions are given in this, right. V3 is equal to 1.02 angle 7.16 degree, This is load flow solution. V5 is 1.0112 angle 2.49 degree, and V4 is given 1.074 angle 4.32 degree, and V2 is 1.03 angle 8.235 degree. All these things are given. Next is the line parameters are given. This is your R and X values, that 0.012, 0.18 plus j 0.11. This is all in per unit. This is also 0.007 plus j 0.04 per unit, and this is also 0.004 plus j 0.0235 per unit. These parameters are given. A fault has occurred at near bus 4, right? A 3-phase fault has occurred, right? So, first thing is, this is bus 1, bus 2, bus 2, bus 3, bus 4, this is bus 4 and this is bus 5. First you have to make that 5 into 5 matrix, Y matrix, right? And when fault has occurred at bus 4, right, that means that voltage at bus 4 during fault will be 0, that means 4th row and 4th column of the Y matrix will be eliminated, right. So, as usual pre-fault also we will make your whatever number of machines are there, accordingly we will reduce, right. Similarly, for your what you call that your during fault condition and during post fault condition, and after that we will write down that power equation how to write, then we will write swing equation during fault and post fault condition. So, this example is taken, or this all the result whatever you see, all the result whatever is given for voltages and other thing, and your what you call that these are all load flow data, detailed load flow data, other thing we will also show everything, and for the exam purpose also all these things will be provided to you, because it is impossible to compute in the class, right. All these things will be provided to you. Your objective is to compute other things very correctly, right. So, thank you very much. We will be back again.